My name is Brian. I'm the principal architect of data and analytics team inside Fellowmind. I'm a fast-track recognized solution architect from Power BI from Microsoft last year, and also certified trainer. If you would like to hook up, then you'll have my LinkedIn address here, and also my blog, where you can find various topics on whatever I'm thinking of. I try to write as often as I can. Today we are going to talk about the differences in the server SQL pool inside Synapse Analytics on how do I manage my data, how do I store it in the most effective way, and how can I use it. We're going to dive into a CSV file, a Parquet file, and an external table in the CETAS command, create external table as. I know there are other implementations of data storage, but this is the comparison between the three. A short agenda. I'll show you how to set it up so you can demo this yourself. I will share the source code for you to do it. Then we'll have some demo on the implementation, and then we're going to pop the hood on the serverless SQL endpoint and see what we are getting from Microsoft. Going to dive into the engine and see what we can work with there, and then I have another demo on how can we leverage that engine to the best use. The setup is based on the New York taxi data from this website. I've extracted the data from January 2009 until August last year. I know that they just released the last quarter of last year. I did not yet implement that, but we still have a lot of rows. We have 1.7 billion rows. I think that should be enough. And I've stored it both as a Parquet file and as a CSV file in order to demo this to you. Data load. Let me see if I can show you that. I also did a pre-recording, but I guess it is working today. So here we go. We just switch the slide. There you go. I extracted the data from the New York City by doing a lookup. Here I'm inside Data Factory. I could also do this inside Synapse, but I have a Data Factory pipeline because then I can copy it wherever I want to. This also works inside Synapse. There are no unused features in this that does not work inside a Synapse pipeline. I'm creating the file names that I need to extract just by doing this. This is an old known feature to create rows just by doing null values and then cross apply them. Then I can get all my file names that I need to extract from the website, and I'm also generating the actual file names that I need to store it as. So this generates all my rows. Here I'm doing a for each loop. So for each file that I get out of this, I'm copying the data from the Parquet file, from the website. Sorry. The source is just a Parquet file here. If I open this, then it is a linked service where in the base URL, I've pasted the URL to all the files. And then these files are then added with the name that corresponds with the period. And then I'm pasting that inside the relative URL, which I've created as a parameter. Then I'm storing this as a Parquet file, just with the file name from the lookup. And by some reason, perhaps someone here knows, but I cannot execute this in parallel. I think it is the New York City website that just locks down the IP address if I try to hit it with a lot of extraction, because I could do this in one for each loop, but to extract the CSV file, I'm doing another for each loop, not to hit the website with a DDoS attack. I'm doing the exact same thing. The source is the same. The destination is just a CSV file, and for the sake of it, I'm just replacing .parquet with .csv. And then the pipeline is automatically saving this as a CSV file. So if I run this, then I get all the data stored in my data lake. And let me see if I can find the data lake for you. I have it here. This is my New York taxi data lake. I have my 164 Parquet files stored here from January 2009 up until August 22. And please note the size of these are roughly around 50 megabytes. If I then go to the CSV files, I have the same amount of files, but the storage here is roughly 2.5 gigs. The same amount of data, but stored in two different ways. So now I have my data baseline ready in order to do the demonstration.
Nice.
Sorry. Oh, I just heard something. Okay, right. Let me just click on here. The serverless SQL pool. Well, I also did some setup to create the serverless SQL pool, and in order to show you that, I will import my. Where is it? Just hang on. It is here. There you go. I created a database just named Chester. I use it. Then I create a schema called New York Taxi. And in order to actually extract data from my storage account, I'm also creating a scope credential. This does not work anymore, so you are more than welcome to copy it, but it will not work. Then I'm creating an external data source. I'm creating the external file format. All of this is documented on Microsoft's webpage on how to do it. And then I'm creating one view and one external table. The view is based on all the Parquet files, creator alter view, New York City, all Parquet, and then I'm pointing to my Parquet files in my storage account with a wildcard. Then I'm importing or selecting all my Parquet files with this wildcard. Remember the format as a Parquet file. In order to create an external table, I do this. I point to my data source. The file format is a Synapse Parquet format in order to compare this. And then I'm pointing to the exact same Parquet files. And if you don't know it, then a create external table as the CETAS command is also creating new Parquet files, but then it is mounting those Parquet files as one object inside my serverless SQL engine, so I can use it as a normal table. This is to be used as a normal view. Then I'm also creating a view for my CSV files, pointing to the same area and then wildcarding my way to the CSV files. And then I'm hard coding the data types here because I've seen that even though I'm using parser version 2.0, not all of the data types are adhered to. I think it is because it is doing some sort of top something on the parser version to try to guess the data types. So this is the command, and this is the setup. And in order for you to see it, I'll just run quickly through this because the create external table Parquet file here is can I move this? Sorry, over here. Move. I hope you can see it. It takes almost 5 minutes to process these 1.7 billion rows. But now I've set it up. I'm ready to do my demonstration.
Right, and we have a quick question.
Sure.
Location of the tables, where are they actually stored?
What tables?
The
external tables?
The question of the location of tables in Synapse Managed Storage, is that right?
Yeah, the external
so your
table.
Parquet files?
Yeah, let me just show you that one again. Here I have my Parquet files. These are the raw files that are imported.
All right, okay.
And let me see. I think I have. I think I get the question now. So where the external table is storing the actual files, right?
I think so, yeah.
Okay, great. Let me show you that. It is storing it here in my Chester data source, and my Chester data source is this. So I actually created a different storage account, just a normal blob storage, and gave it an external data source name, and then I'm storing it at this location on a blob storage. It is still just a blob storage stored as Parquet files.
Cool, thank you.
So okay, great, no problem. Yeah, 5 minutes to handle these 1.7 billion rows. All the performance talk, well, let's get back to that one. Now we're going to do the comparison and to see what is most effective on my data storage. And I have cheated a bit and prepared something for you here. If I do this, this is my select statement on my all Parquet files, the raw Parquet files. If I just do a count big here, then this should, it did for an hour ago, finish in approximately 6 seconds. Now it took what, around 7 seconds, but I still get the 1.7 billion rows. If I do the same thing on the external table, this is much faster. The external table returns the count big rows way much faster. Now I won't start this because then I actually have to wait around 5 or 10 minutes for it to stop again, but this will never finish. If I do a count big on my CSV files on 1.7 billion rows, I think it finishes, it does not finish within the thresholds of 30 minutes. So I won't start it. This is just a, trust me that this won't finish if I do a count big on my CSV files. Okay, what happens if I do a filter predicate? Well, the same thing, count big, but just where the passenger count on my New York City taxi data is 1. This takes around 33 seconds, perhaps longer, but now it needs to traverse all the Parquet files, and if it cannot read the actual index from the Parquet file, it needs to read the raw Parquet file, extract it, and then count the rows. Because the passenger count is now equal to 1, so it has to filter all the rows. And we should be there. It's still running. While that is running, I will, in a couple of seconds, also show you to do this on an external table, and it will perform much better. Let's see. An hour ago, this only took 23 seconds. Is the demo cost here? No, there you go. And this took 51 seconds. If I do the same thing on the external table, it should perform way much faster. And even though I'm still accessing Parquet files, external table is a Parquet file. This is a view on a Parquet file or more Parquet file, and it is completing in 18 seconds. So the external table is faster when doing filter predicates. And oh, there's a question. Should we take that? What happens with the external table structure if a column is dropped in the CSV file? Yeah, exactly. As Sanjay says, then the column will be null. Okay, great. So back to the slides. Let me move this away. So the comparison here. So raw Parquet files are fastest when doing a full load. External table are fastest when working with a filter predicate. I'll get back to this later because we can do some partitioning here. CSV files are okay for smaller datasets. I've tested this. If you are below 100 megabytes, then by all means go for the CSV file because you won't see any difference because of the parallelization inside Synapse. It's just the same thing. Well, what are we getting outside of the what are we getting inside of the Synapse Analytics workspace of the serverless SQL pool? What engine are we getting? How is this performing to us? So back to the code. If I just, if I do a normal select version, then I'm presented with, I'm actually getting a normal Azure SQL Server of version 12.0. This is the same version you would get if you spun up a SQL database inside just a Azure SQL database. The exact same version with the exact same build number. But what if I also look at the server properties? Well, then things start to get interesting. I'm still getting the version 12.0, but the engine edition is now 11. This is not documented as perhaps it is now, but engine edition is more or less that no, you're not getting any DMVs. No, you're not getting any execution plan, and you cannot performance tune your queries because you cannot go deeper inside what is happening inside my engine. So Microsoft has cut off features in the SQL Server, and I know this is I think this is because that the SQL Server is a shared service, so you cannot just do DMVs to see what other people are doing. I get that. But what about the recovery model? Because if I want a fast running SQL Server, I'm actually interested in perhaps a simple mode in the recovery model. But here in the recovery model, it's full. I don't get why is that full, because I'm not doing transactions inside my serverless SQL pool. I cannot do that. I'm only doing select statements, and select statements, if they crash, I can just start over. I don't need a full recovery model. The compatibility level is 150. I think this will change because they just released 160. I think this will change in a short while, but this is just my own thought here. But what about the data files? Do I really need data files inside a serverless SQL engine because I'm not accessing data inside the server? I'm accessing data inside my blob storage. Well, yes. I also have a log file by some reason. And the max size for the rows are unlimited. It's -1. So the server is having a rows file, data file, where it can just pop in files, or sorry, rows by some reason. And the log file is quite big. And why do I have a log file? Because yes, I have it because I'm in full recovery mode, but to my extent, I don't need it. It is still there. I'll get back to you why it is there. So back to the slides. So the documentation from Microsoft, what does this say to us? First of all, it says you are only allowed 400 gigabytes of data in the resource sets between concurrent queries. What does that mean to us? Well, if you have a parallel loading data warehouse and want to read in your data as fast as possible, make sure to remember that you might have to wait for the loading if your total amount of loaded data is larger than 400 gigabytes. And the last thing here is the concurrency is perhaps self-explanatory, but if you have a lightweight queries, it's a matter of how many you can throw at the engine, it will still answer. But if you have more complex queries like a join and then a filter predicate and so forth, you might have to wait for the data to be returned. So these two documentation limits are hitting us if we need to load complex queries and data more than 400 gigabytes. But what about the external table's performance here? The external table works by metadata and is defined in the SQL database and as a pointer to where the data is stored. The data can be located on a data lake or another Azure SQL database or something different. When data is needed, the serverless SQL database reads the data into the engine via the external tables and then returns it to the end user or the application asking for it. It is heavily implied in the documentation that Polybase is used for this. And for you who don't know what Polybase is a technology introduced within SQL Server 2016. Yeah. And it is made to enable SQL Server to read data from non-SQL Server sources. This also makes sense because I'm not reading a SQL Server source, I'm reading a file stored somewhere inside Azure. But what about this small comment here? Temporary table. Does this mean we have a TempDB? It does says temporary table, so a temporary table in the SQL Server, I need a TempDB. So do I have a TempDB? Let's, oh, sorry. Let's see. Do I have a TempDB? If I run this, then it should return something to me if I have a TempDB. I cannot browse my way to the TempDB. It is not there. I can only find master and default. But if I run this, I'm actually getting data. So I have a TempDB inside the serverless SQL pool. And this is some different tables or views that I can query. And it is okay for me to query some of them. But all of those with a hashtag for a TempDB table, I'm not allowed to query. And what if we look at the TempDB files? Well, the TempDB files, let me expand this. The TempDB files are, I have one log file, and that is fine because I'm still in full recovery mode. And then I have 4 data files here, 4 data files with a maximum size of roughly 100 gigabytes, depending on how you count it. But let's just say this is 100 gigs. And this corresponds exactly to 100, 200, 300, 400 gigabytes of data concurrently returned to me as an end user. So this must mean that every time I query my data from my blob storage, the data is loaded into some sort of temp table inside my Azure Synapse pool and then returned to me as an end user. Let me minimize this again. And then I need to be quick here because I have this and this. Yeah. If I start to run this, it should give me enough time to show you that. Oh, there's a question. How do you get the size of a particular file loaded within serverless? If the size of the file connection single query. Yeah. Actually, if I go back through my select statements here, if I do this, then if I go back to the messages, then it will show me how much data it has actually read through the Synapse endpoint. This does not correspond with the amount of data stored within the blob storage, because if you are reading a Parquet file, it actually decompresses the Parquet file and reads the data through the engine. Yeah, I hope that was answer enough. Well, back to the demo here. If I run this, this should give me enough time to show you what is happening inside the TempDB. If I run this, and then I run this in the same time, I'm looking for another TempDB table. Come on. Sorry for the flickering here. Is it done already? No. Come on. Normally it creates a new temp table here at the top. Come on. Is it done? It is done. Let me try it one more time. You need to be lucky. This is the demo ghost. If this doesn't work, I'll just tell you what is happening. Thank you. Thank you, Justin. Yeah, right. Okay, this doesn't work, and that's fine. What I was about to show you is that it actually creates a temporary table when it needs to return my count big here, and that temporary table I'm not allowed to query. Normally, I'm allowed to query my temporary tables in my TempDB on a normal SQL server, but if I then do a select star from TempDB and then the temporary table name, I'm not allowed to query that for some reason. So the TempDB is giving me these 4 data files of 100 gigabytes each, and if we then can agree on that the data is loaded through the TempDB, because this corresponds 100% with the 400 gigabytes of data that is allowed under concurrent queries, then if a normal TempDB is implemented inside the SQL Server, then I'm also throttled by the GAM, the SGAM, and the FPS, and so forth and so forth. And it seems like if this is implemented in a best practice way, then I'm only allowed 4 cores on the serverless SQL endpoint, because I have one TempDB file group for each core. And without further discussion, because this could take a whole day, I think perhaps would 8-disk be better? But a comment here is that if you know Polybase can only handle 32 concurrent queries. So if we saw in the first documentation, then there's an unlimited concurrency about how many queries I can go through. But if it uses Polybase, then I'm only allowed 32. So there is something not fitting here. So considerations on the serverless SQL pool. Well, if I do this on a serverless SQL pool, take care of the filter predicates, because the external tables are loaded to the serverless SQL pool inside a TempDB, and a TempDB has no indexes. So it is all heap tables and with no performance optimization in place. So take care of your filter predicates. And if the server can, it will push the search predicate to the data lake as query folding. But if it cannot, then it will load all the data in TempDB and then do a heap search. So what does this give us? Well, if I do a join on 100 rows per table, that's fine, because that's just nothing. That's a heap scan that is okay. But if I do join 100 million rows per table, well, not so funny, because a join on 2 heap tables with more than 10 million rows, that won't be funny for us. And then I saw in November last year that Microsoft documented in this link here something different. Is that queries processes the entire dataset and don't benefit at all by partitions. And I know some of you might shout now, but just hear me out. So even though you're building partitions inside your data, try to manage the reads. All the data is scanned every time. An example here, I have partitioned my data in year, in the folder, and in subfolders by month. If I then do a query on this with a filter predicate on the order date key in order to find these rows that I need, change slide, there you go. Then it scans all 36 megabytes of data, but I'm only returned 1 megabyte because this is the result of my filter predicates. So can I do anything about that? And you can see here the one file that it is trying to access is actually 9 megabytes, but it still scans the entire thing. But we just have to do the partitioning correctly and the filter predicates. If I do the filter predicates like this and ask for the file path equals year equals 2022 and file path 2 equals mon equals 1, and then I rerun the query, then I'm only scanning that one Parquet file, which is only 9 megabytes instead of 42, and of course I'm returned the 1 megabytes of data. Yay! And then it works. Then my partitioning inside my storage account is now working. But wait. Am I then stuck with a view and cannot create an external table? Well, because if you define an external table over a partitioned data set, as to the documentation, then Synapse Serverless SQL pool will not be able to benefit from the partitioning because it creates its own Parquet files in a storage account, and then it will always read the entire bunch of files. So right here, the external table will not help us. But what if I have all the time in the world to do my queries? What if I'm okay with the data warehouse is taking 7 or 8 hours to load? Well, then we are presented with this. Each query has a maximum of 30 minutes. So even though I can wait a weekend or a day, well, each query will be killed at around 30 minutes. And in actual real world, it is killed, I think it's around 31 minutes, something, because it has a trigger that it needs to go around. So please take care when you build your serverless SQL server and build the views, the Parquet files, the external tables, and so forth, and adhere to what the server engine is trying to give you. So I have 3 possibilities to implement my data storage and my data manipulation. I have views. I have my create external table as, and then I can actually, Power BI can connect directly to the raw Parquet files. I will show you that later. And this could be some remembering points on when to choose what. If I do a view on a CSV file, then I'm only moving data once through the serverless SQL endpoint, because I'm storing it inside my blob storage, and then when I need it, I read it directly from the view. And if I need partitioning, then do it correctly and according to the business needs, and implement the query to help adhere to the partitioning, and so the query folding can be processed down at the data lake. The CETAS is good for pre-calculated data. If I have a view that is too long, that does not respond to the business fast enough, then do a CETAS based on that data. But it moves the data twice, because it moves the data through the Synapse Serverless endpoint from the CSV file and then stores it at a Parquet file. And then again, when you need to read the data out of the CETAS, then it reads the data from those Parquet files out to the end user or the application. So you pay for the data movement twice. The raw Parquet file, it can be handled from Azure Data Factory or Synapse pipelines, of course, when you store the data as Parquet files. And it can be read from Power BI out of the box. And do you get partitioning? Yeah, well, not if I use Power BI, because Power BI would like to read the entire data unless you set up some incremental refresh on your Power BI. Let me show you that one. If I need to read data in from my storage account, my Parquet files, I need to find this. Go. Now, what happened? There we go. And I'll just use a blob storage. Blob, not a block. Blob storage as a blob storage. And my Parquet files are saved. Oops. We just cover this one. Yes, sure. Power BI can read from the serverless views, of course, because those are exposed just like a normal view would be on a SQL server. So of course you can do this. This is just to demo that you can actually read the raw Parquet files outside of the Synapse Serverless SQL pool and save you money on the processing through the serverless. If I then choose the New York's taxi, then I'm presented with both the CSV and the Parquet files, but I can handle that inside my transformation. Let me just move this so you can see it. There you go. It's a bit big. There you go. And then if I text builder begins with, I only want my Parquet files, then I'm good to go. Now I only have my Parquet files, my actual Parquet files here, and not the folder. And then if I click this, then Power BI will now help me build a joint data table based on all of these Parquet files. Just hang tight. There you go. This is my actual data from my Parquet files joined into one table. There you go. And then I'm getting the helper queries. I don't like helper queries. I have a blog post on my blog on how to remove these and just get only one of this. I'm doing some pretty advanced stuff here inside my my mQuery to remove the helper queries. If you want that, then just look at my blog. But now I have my data loaded from my raw Parquet files, all 1.7 billion rows. This is just a subset, I know. But now I can load this into Power BI and start working with my data. Then I'm reading data outside of my serverless SQL pool. I'm not paying those, what is it? Is it $5 per terabyte through the serverless endpoint? I'm only paying for what I'm reading from the blob storage, much cheaper. And if you store your data as Parquet files and want to read it inside Power BI, then this is an okay, from my point of view, go-to approach for loading this. I will not click apply here because then it starts to load all 1.7 billion rows. Thank you. Yes, $1 per terabyte. Yeah, $5 per terabyte and a minimum of 10 megabytes. Exactly. Thank you. So for the sake of this, I will not apply my changes. So key takeaways here from this session: work with the data to fit the known TempDB configuration and the file sizes. I've actually done this because we ended up with files filling, storing more than 400 gigabytes of data, and then we started to do partitioning, and then we got a much better data delivery out of serverless SQL pool. And know that you only have 100 gigabytes for one temp table because it needs to be stored on one data file inside the TempDB. And you also only have 1 gigabyte for CTE and for table variables. So if you start working with CTEs and table variables and you start to see out of memory errors, then you are loading more than 100 gigabytes inside a CTE. If you can, refit the data pipelines to partition your files to fit the engine. I know Microsoft would like to have more smaller files, but it depends on the usage scenario that you just saw. If I have smaller files and I have many of them and I don't do partitioning inside my blob storage, it needs to read the entire thing all over again. So if you can do incremental loading, then do it also in Power BI, because then you only, of course, read out the data that you actually need. And if you want to do a join, then if you can, move it to after Synapse Serverless, because joins in Serverless is just, then it reads the data into a temp table on a heap, and then you have to do a join on 2 heap tables, and that is not funny. It does work for smaller data sets, but if you get up on those very, very large data set that Microsoft is supporting inside Synapse Analytics, then if you can, move your joins to after Synapse Serverless, and here Power BI does a very, very good and decent job. Are there any questions I haven't seen? I'm just scrolling through the questions here.
No, I think you're good. It's just the one last question at the end at the moment.
So if we have to do data manipulation so store it as Delta first, do transformation and store it back as Parquet to save cost. Great question. So if I need to do data manipulation, then store it as Delta first. That actually depends on the user scenario from my point of view. If you want to do data manipulation before the storage, I would do that in a wrangling data flow because I can do data manipulation there. If that is possible. I know that it costs a bit more money to do data wrangling in pipelines than it does in a join. But if you have enough data for that, then I would do it in a wrangling data flow, or else I would do it in a join. And then if that view is performing good enough for just a normal view based on your raw tables, then that's fine. If it is not performing adhering to the business needs, then do the view, do a CETAS, and then query those CETAS files and load them into Power BI. That will be my best answer here. Sanjay, I hope that's fine. Assuming you can't do data manipulation language over serverless files. Oh yeah, David. You can do data manipulation language over serverless files. You can just do a view, and then based on that view, you can do whatever data manipulation language you wish, with a few limitations. I think you can't do recursive CTEs, and you can't do things that demands a physical storage because you don't have a physical storage inside. Even though we saw we had a data file, you are not allowed to store things in that data file inside the Synapse Analytics workspace. But you can do pretty much everything inside T-SQL that you normally can on a SQL server, but you cannot do that on a serverless SQL pool.